Hi everyone, and welcome to today's video on what is a rate, an introduction to rate laws. This video will answer the following questions. What is a rate, and how can the instantaneous rate for a reaction be determined? So for the first question, what is a rate? A rate is something, anything, divided by time. So for example, a heart rate is the number of beats per minute. A birth rate is the number of births per year. Speed is miles per hour. Can you think of some other rates? Write down a few more examples on your own. How are rates used in chemistry? Well, during a reaction, the concentrations of reactants and products are constantly changing. And so in chemistry, we are interested in the change in concentration over the change in time. That's how we're defining a rate in chemistry. The shorthand way to say that is delta square brackets, which is representing concentration, over delta T, your change in time. So we take a look at this decomposition reaction. Two hydrogen iodide molecules are decomposing into one hydrogen molecule and one iodine molecule. Let's take a look at what a graph of this reaction might look like if I were to graph concentration versus time. So I'll put HI on the graph first. If I start at the beginning of my reaction, my HI concentration is high, and there's no products necessarily in my reaction container to start with. So HI is way up here. And as time goes on, the reaction will proceed kind of like this. I'll draw a little curve here. That's kind of just a rough sketch of what that concentration change might look like. So how can I calculate the instantaneous rate at any point along this line? Well, if you remember from math class, I can draw a tangent line to the curve. So if I pick a few points on my graph that I'm interested in, I can draw a tangent line to help me figure out the rate at any given point. So I'll start with this first one. We can just draw a tangent line on that like that. And this would help me note the concentration and the time at that particular point. And if I notice the steepness of this slope, it's changing very quickly. The concentration of HI is decreasing very quickly. There's a lot of HI molecules to react with each other at the beginning of the reaction. And so that drop in concentration happens very quickly. I notice just over time that it generally flattens out. So as I get more products in my container, they are getting in the way of these HI molecules finding each other. And so the concentration doesn't change as quickly anymore. But I can do the same thing for any point along this graph, as I can just keep drawing tangent lines, and that helps me to find the instantaneous rate. Okay? If I make that connection back to my equation that I showed you earlier, the rate is going to equal the negative change in concentration of HI in this instance over the change in time. And if you remember, that relates directly to your slope. The slope is rise over run, which is your change in Y over the change in X. So that's how all those things are related here. This is a negative rate because HI is being used up. So from start to finish, that rate will overall be negative. If we were to draw a curve for what either of these two products might look like, it would look a little different. So I have to know here that generally, so my products are being produced, which means instead of being used up, the concentrations aren't decreasing over time. The concentrations will increase over time, and so they'll have a positive slope to their curves. The other thing to note is just somewhat with the ratio. For every two HIs that react, I get one hydrogen molecule and one iodine molecule. So it's half as much as my reactants. So my steepness of the slope should be half as big kind of from the start. So if I sketch that out, at the beginning of my reaction, I don't have any H2s. I'll just pick H2 for right now. If I don't have any H2s in my reaction container to start with, so that actually does start from 0. So that'll be something kind of like this here. And again, that's just a really rough sketch showing you that Generally, your concentration for H2 is going to increase over time. I can still find my tangent lines at any point along the curve, and that just tells me the relationship again between H2 and HI. So to review again what was in this video, what is a rate? A rate is anything divided by time, and in chemistry that's going to be the change in concentration over the change in time. How can the instantaneous rate for a reaction be determined? Simply draw the tangent to the curve and then calculate the slope of that tangent line using rise over run, or delta y over delta x, which again will be your change in concentration over your change in time. All right.